Hello everyone, let's try to have another board problem under the category of the technical engineering and hydraulics. This is now our board problem number 12. Let us now start solving a problem. Our board problem in this session is actually a board questionnaire during the May 2022 Civil Engineering Licensure Examination. And this is the situation. A rectangular gate 1.5 meter wide and 3-meter high is vertically submerged in water with its top edge horizontal 2 meter below the water's surface. And in this given problem or situation, you are required to solve for the following. For the first requirement, we need to evaluate the total force acting on one side of the gate in kilonewtons. For the second requirement, we need to obtain the location of force from the center of gravity of the plate in meters. And lastly, obtain the location of force from the liquid surface in meters. Let us now try to solve the problem, and let us concentrate first on the first requirement, that is, to evaluate the total force acting on one side of the gate. As shown below now is our figure. In order to calculate for the total force acting on one side of the gate, we need to calculate for the pressure. And the pressure formula is equal to unit weight of water times the depth and times the area. As we can see now, there are three items encircled in our given figure. The 2-meter distance or depth and the 1.5-meter depth, including the dot. This only shows that we need to add 2 meters and 1.5 meters. It is going to be our lever arm or perpendicular to distance to the point encircled. And the formula that we're going to use to solve for the force acting on one side of the gate is equal to unit weight of water times the depth of 3.5 meters and times the area. Coming up next, we need to compute for the area of the encircled object, 1.5 times 3 meters. Doing the direct substitution now, we have our equation as pressure equals 9.81 times 2 plus 1.5 times 1.5 times 3. Finally, we have now our value for the total force acting on one side of the gate, and that force is equal to 154.91 kilonewton. After computing for the total force acting on one side of the gate, let us now compute for the location of force from center of gravity of the plate. In order to solve for the location of force from the center of gravity of the plate, we need to calculate for the value of E. And the formula for E is equal to I sub S, or the inertia, over S sub S. Now, if we're going to calculate for the I sub S, we have a formula of BH cubed over 12. Substituting the values, we have 1.5 times 3 cubed all over 12. And then our I sub S equals to 3.375. Coming up next, we need to calculate for the S sub S so that we can easily obtain now the value for A. If we're going to calculate for S sub S, it is actually equal to area times the Y. That is why S sub S now is equals to 1.5 times 3 times 3.5, and S sub S equals to 15.75. And finally, we can now solve for the location of force from the center of the gravity of the plate. E is equals to 3.375 over 15.75, and the value of our E is equal to 0.214 meter. Let us now try to solve the last requirement, location of force from the liquid surface. D is equal to 2 meters plus 1.5 meters plus the value of E, which is 0.214. Finally, the value for the location of force from the liquid surface equal to 3.714 meters. Thank you very much and God bless us all.